Today we're going to learn how to solve a system of equations using the comparison method. The first thing we have to do is to understand that the system of equation refers to two equations, two lines in this case, that are going to have a point that is common to both. The solution, x comma y, has to work, make both equations true. In a graph, we're talking about the intersection of two lines represented by those equations. Here we have the two equations, and the thing that makes this a little bit difficult is the fraction when we go to solve, but it really makes it easy for graphing because you get the y-intercept, which is -1 on the first line with a slope of 1/3. The y-intercept is -6 on the second line with a slope of 3/4. Now they do intersect at a point. They have to intersect somewhere because they're not parallel. And that point of intersection sometimes is obvious, but other times we're going to have to figure out a better way of finding out what that value is, the x and y. We're going to solve it algebraically. So the concept works like this. You have to say if y is equal to an expression in the first equation and y is equal to an expression in the second equation, then those two expressions must be equal. Technically speaking, the this must equal the that in those two equations. So here we have our two equations, and it basically means that the 1/3 x minus 1 has to equal the 3/4 x minus 6. So we set this up, and here I said the problem is with the fractions, right? You want to make sure that you don't lose, don't approximate, don't round. You want to keep those fractions intact, their exact values. So the easiest way to do this is to write every term with a common denominator, multiply through by what that lowest common denominator is, so that we can just strike it out of there, and we're left with whole numbers. Now we can just solve this as you normally would. You're going to bring the x's together, so I'll bring the 4x to the right, and I'll bring the 72 to the left, and we simply simplify both sides, divide by the coefficient of the variable to get the value of x. Now remember, we need to find the x and the y. So that means we're going to plug the x equals 12 into an equation to find out the y value. I'm going to use the first equation, but it actually doesn't matter which one you use. Try to use the one that's going to be easier. So I'm going to replace that x with the 12, multiply. Doesn't always work out to a whole number, but in this case it's wonderful. 4 minus 1 is equal to 3. We have the x value is 12, the y value is 3. Our solution is the ordered pair 12, 3. So the issue here is, can you handle those fractions, right? You want to get rid of them first off. Here's another question. Now the difficulty here is that the y is not isolated. So our step 1, where we have to isolate y in both equations, is a little more challenging. So I'll rewrite this and I'll put it in a cloud to keep things organized. You put the y term by itself and you divide through by the coefficient of y. Clean it up. Now, I could have left that as -3/2. The -1.5 works just as well. With the second equation, I'm going to put the y onto the other side, where it's going to be positive, bring the 9 to the left, and now I have y equals 3x plus 9. Now you could have just left the negative y there and divided everything by -1, but you had to remember y has to be positive and it has to be on a side by itself. Now we have an expression for y in the top cloud and an expression for y in the bottom cloud. So we make those two expressions equal to each other. This equals that. I'm going to bring the x's to the left this time so that you get 3x plus 1.5x, and the positive 9 goes to the other side as negative 4.5x and 12. Divide through by the coefficient. Now here's another issue. When I do this division, I come up with a repeating decimal in the calculator. And you're not allowed to use repeating decimals because they're not exact. So use the second PRB and the second ABC to turn that into an improper fraction. Because now you have to plug that into one of the equations. I have a choice of the first or the second. I'm going to use the second equation because the y is easier to calculate there. It's by itself. And I'm going to replace -8/3 in for the x. Calculate it out to get the value for y. X is -8/3, y is equal to 1. You put them together into an ordered pair for your final solution. hopefully everything there makes sense to you, and we're ready to try some other examples.